Alright, in this video we are going to look how to write the equation of a circle using a process called completing the square. This video is going to assume that you already have a basic knowledge of how to complete the square with quadratics. So if you don't know how to do that, please go to the link and watch that video first. And so what we've got here, it says find the center and radius of the circle, and it gives us this, and this doesn't seem like it would describe the equation of a circle. It looks very different than what we know the equation of a circle to look like. But what I know is that if I can write this in this form, then I'll be able to identify the center and the radius. The center will be HK, and the radius will be R. So our goal is to transform this to make it look like this. And what I'm going to do that is I'm going to complete the square twice. First off, I'm going to complete the square with our x values, and I'm eventually going to kind of transform that to make it look like this. And then I'm going to kind of complete the square in here with these y values, and it's going to make it look like this. So let's start. If I take x squared minus 6x, I know that if I add some number there, it will make that a perfect square. So let me kind of copy down everything else. And that equals 0. So first off, I got to say, okay, what number here would complete this square? And if you have a good knowledge of completing the square, you'd say I'd take this b value, I'd divide it by 2, which would give me a -3, and then I'd square the -3 to make that a 9. And anything I do to one side of the equation, I have to also do to the other. Okay? And that creates a perfect square trinomial right here. Now, let's look at our values in red, and let's try to complete the square over here. Now, if I look at, I already have kind of a constant there, but if I were to take that 10, and I were to do the same process, and were to divide it by 2 to make a 5, and then I would square the 5, you'd say, oh, I'd have a 25. So it appears that this part over here in red is already a perfect square trinomial. So we have a perfect square trinomial here, and we have a perfect square trinomial here. Well, what you hopefully know about completing the square is that if I have that perfect square trinomial, I can write it in condensed form. If I were to factor this, you would get x minus 3 times x minus 3, or I could just write that as x minus 3 squared. Okay? And then I do the same thing with my y values. You know that, okay, well, if this is a perfect square, I could factor it, and it would be y plus 5 times y plus 5, or in other words, y plus 5 squared. So what we have now is this equation. I'll just combine the 0 and the 9 to make 9. And so I now have x minus 3 squared plus y plus 5 squared equals 9. And by completing the square twice, once with the x's and once with the y's, we've created the equation of a circle in this center radius form. And now we're able to answer the question at hand, find the center and the radius. Well, the center of this circle is just going to be 3. And remember, it's kind of the opposite sign, so it would be a -5 for the y coordinate. That's going to be our center of the circle. And then the radius of our circle is not going to be 9, but it's going to be what number squared gives us 9, which is 3. That's going to be our radius. Okay? So the moral of the story is that when you're given an equation that doesn't look like the center radius form for a circle, you're going to have to complete the square to get there. I've showed you one example. I want you to pause the video and try this example on your own, and then we'll jump into it after that. Okay, as I'm looking at this, it looks like before we do this, before we can even do any completing the square, I'm going to rearrange my terms. I'm going to rearrange them so the x's are together. So I have 4x squared. Then I'm going to kind of move the minus 16x over here. And then I know that I'll probably eventually need some constant there. But then let's take our 4y squared. And then let's take our minus 24y. And then I know that I'm going to need some constant there. And then I have my plus 51 equals 0. But for this problem, what I'm seeing is that I think that 51 is kind of getting in the way. Like we don't have like the already completed perfect square right here. And so what I'd like to do is I'm just going to kick that 51 over to the other side of the equation by subtracting it from each side of the equation. Just kind of, I didn't really show it, but kind of subtracting 51 here and subtracting 51 here. And now what you've got is is we're going to complete the square twice. I'm going to try to create a perfect square here and a perfect square here. Now this is really a matter of preference, okay? But what I see whenever I look at this is I see a bunch of numbers that are divisible by 4. So if I divide both sides of my equation by 4, it's going to make this completing the square process a whole lot easier. Divide that by 4. Divide that by 4. But then anything I do to the left side, I got to do to the right side. Okay? And now we are here. Now I'm ready to complete the square twice. Okay? I'm going to take my middle term. I'm going to divide it by 2. I'm going to square it. And that means I add 4 there. Anything I add to one side of my equation, I have to add to the other side. Now I'm going to do the same thing for my y values. I'm going to take my middle term, that b value. I'm going to divide it by 2. And then I'm going to square it. Anything I do to one side, I have to do to the other. Now, what we have is we have a perfect square trinomial and a perfect square trinomial. So, if you've got your knowledge of completing the square, your pattern here is that the factors of that are going to be x minus 2 squared. And then we're going to kind of just add. And then for our values over here, our shortcut that whenever I factor that, it's going to be y minus 3 squared. And that's going to be equal to all this stuff. Now this stuff over here, this is not going to make a nice or pretty number, but let's just kind of try to get a common denominator. 4 would be 16 over 4, and 9 would be 36 over 4. So whenever I take all those and I add them, this actually might not end up that bad at all, because that's going to be 52 over 4 minus 51 over 4. That's going to give me 1/4, which is going to be the right side of our equation. And now we've got our circle written in center radius form. So we're able to identify the center of our circle. Our HK is going to be 2, 3. That's going to be the center for those values. And I'll go ahead and label that. That's going to be the center of our circle. And then the radius might be a little trickier to identify, but if you know, I kind of come over here, that some number squared equals 1/4, you might just know what that is just by looking at it, but if you got to do some math, you could take the square root of each side to solve, and that's going to actually be 1/2. The radius of this circle is just going to be 1/2. So the completing the square process was a little bit tougher in this example, but just kind of keep the general idea of what we're doing in mind. I'm trying to write this in the form of this, because once I have that, I can identify HK, which is the center, and then the radius, which is R.